Okay, another Venn diagram problem for you to practice. Given a packet of cards, if we were to pick out two cards at random, what is the probability that at least one card is a red and diamond and a picture? Okay, so picture cards or these cards here. Diamonds or these here, and red cards or these cards here. Okay, so we're going to pick out two cards. What is the probability that that at least one card is all these here? Okay, so again, draw the Venn diagram. Well, you could probably do it without drawing the Venn diagram, but learn to draw the Venn diagram anyway, and then jump to the tree diagram. So this here would represent your first card, second card here, and well, we're saying at least one. So well, anyway, do what you had to do. Have a go, but learn to draw the Venn diagram. I know you could probably jump to it, but learn to draw the Venn diagram. So press pause and have a go. Okay, so if you look at it, it's saying a card has to be a red and a diamond and a picture card. Well, if you look at this here, red are all these cards here, diamonds are all these ones here. Now, if it's a diamond, it's automatically a red card. So your Venn diagram will look quite strange. Hang on. So let's draw it. This one here will represent red. Okay. The thing is, diamond is going to be within this. So it's going to be like this. So I'm just going to use a D for diamond. Okay. And picture would be something like this. Okay, and then you've got your whole set here. So red cards would be well, there are 26 red cards, but 13 or diamonds. So that means 13 here, 13 are diamonds. This here would be picture. Okay, but the thing is, of the diamonds here, there are three picture cards. So I'm going to move the 13, the 13 within the diamond here will move into here. So this would be a 3, and I'm going to change this to a 10. Okay, but if you look at the red, well, there are 3 red cards here that are picture cards. So you've got to move that. Hang on, you've got to move that here. 3, okay, and then change this to a 0, to a 10, sorry. So here, and then picture cards, you've got 6 out here, and then you've got 20 out here because you've got to take care of these 20 cards here, okay. So your Venn diagram will look like this. So that circle that small circle in the middle represents diamonds. So yeah, so double check everything should add up to 52, and we've got 20 here plus another 20 here, so that's 40, and then plus 12, so that's 52. Okay, so your Venn diagram will look like this. Now you want and, so red and diamond and a picture. So you want the intersection of all 3. So you've got to look for a segment where well, if you come from this segment here, you basically will be red, picture, and diamond as well. So but remember, you've only got this tiny segment in the middle here that represents all 3. Remember, and because you've got an and here, it means the intersection of all 3. So it basically means the intersection of all 3. But because our Venn diagram is quite strange, the intersection of all 3 will be here. This one's not an intersection of all 3. This one here is not a diamond. Well, basically, if you look at the diagram here, if you want to satisfy all these 3 conditions here, red and diamond and a picture card. So it can only come from these three cards. Now these three cards here are or right in the middle here. Okay. So now let's jump to our just trust me that the Venn diagram looks like this. Okay. And now we're going to pick out two cards. So two cards would be like this. So let's define good as being red and diamond and picture. So the probability of good would be it has to come from this segment here. So that would be 3 out of 52. This one must be 49 out of 52. Now, suppose we just picked out a good card. Let's say we just picked out the queen of diamonds here. So there's only two left. 1, 2. Well, the probability of you getting another good card would be 2 out of 51. Okay, bad would be 49 out of 51. And suppose you just picked out a bad card, probability of you getting a good card again, good card would be 3 out of 51. Probability of you getting a bad and a bad, after getting a bad card, the probability of you getting another bad card would be 48 out of 51. Okay. Now the question is saying probability of at least one card, at least one out of the two. So if you get good, that's a good outcome because it's at least one card is good. Here, good and bad. Well, you've got one good card here, so that would be a good outcome. And then hang on, this one here is good. So a bad card and a good. Well, then this is a good branch because at least one card is good. Bad, well, the overall outcome will be bad. Okay, so we are interested in 3 branches here. Okay, rather than working out all 3 branches, I'm just going to work out one branch here, bad, and then get one, take away that answer. Okay, so hang on. So our answer will be hang on. So it would be 1, take away the probability of bad and bad. If this is confusing here, then you can work out this branch and then add it to this branch and then add it to this branch here. But because rather than working out 3 branches, I'm just going to work out one branch and just get 1, take away this branch here. Okay, so what is the probability of probability of bad and bad will be 49 over 52 times 48 over 51. Okay, remember multiplications are more important than subtraction, so you've got to do this first anyway. So we don't really need the brackets. Okay, anyway, let's work this out. 49 times 48. Hang on, clear this. 49 times 48 equals 2352. 2352. And then bottom times bottom. 52 times 51. Calculator, clear it. 52 times 51 equals 2652. Is that? Yeah. Okay. So now it's just getting this, take away this. I'm going to rewrite the 1 as a fraction, as 2652 over 2652. Remember, these two this whole number here is actually 1 because the two numbers are the same. I'm just rewriting the 1 as this number here. Okay, take away this number here now. So that will be 2352 over 2652. Now, so we've got 2 fractions, but the 2 denominators are the same here. So we can just get the top take away top, basically. So I'm just going to merge the 2 fractions together. The 2 denominators are the same, so we're allowed to merge the two together. So it's just a matter of 2652 take away 2, 3, 5, 2. So that would be 0, 0, 3 here. So it's 300. So it's 300 over this. Okay. Now jump to a calculator and turn it into a decimal. Clear this. 300 divided by 2652 equals roughly 0.11. So that would be our final answer. Okay. So given this thing here, given this whole thing here, if we're going to pick out two cards, the probability of at least one card being red and diamond and picture, basically these three here, the probability of one of the two cards being at least one of the two cards having one of these three cards here is 0. What was it? Whatever the answer was earlier, I think it was 0.11. Okay, so the overall answer would be this.